We'll just continue with the final examples here and extra little pieces they may bring. So 4 doesn't provide a picture. So this is where the beauty of how we name things comes into play. Triangle ABC. You can draw any triangle. You can label ABC anywhere you want. A is 32. B is 81.8. Side A must be right here, 42.9. And we want the measure of side C. And that's where that naming convention of the capitals and the lowers help us keep things straight. So now when I look at this picture and I think about wanting to find C, little c right here, the first thing I think about is, does law of sines work? And I know these two opposite, but I don't know these two opposite. But it's not as dire as it seems because I do know 2 of the angles. And so the first thing I can do is I can find that angle C is equal to 180 minus 32 minus 81.8. And that is a step that most kids forget. They think they don't have enough information, but remember, if you know 2 angles, you can always find that third. And so I know that angle C is 66.2 degrees. Now I can go ahead and I can set up a law of sines, and I can say the sine of 32 over 42.9 side angle pair is equal to the sine of 66.2, what we just found, over C, the one we don't know. And then we are going to cross multiply. And when we do that, we find out that C is equal to 74.1. When we look at the next 2 examples, they get into a little bit more real life problems because they talk about things that happen with surveying. So somebody is by a river and they want to calculate the distance across the river. Not something you can take a tape measure to. So if we measure the angle between your observations at 2 points on the shore, one on your side of the shore and one on the opposite side, to be 28 degrees. And then the distance between the observer and the point on his side of the river, so this is the same side of the river, is 300 feet. And the angle formed by him, the point on his side of the river, and the point on the opposite side of the river, so this is across the river, is 128 degrees. So how far is it across the river? So here's our R. There's where our river runs. And so when we look at what we have, it would be always look to see if law of sines works first. And do I know, here's angle and its partner, do I know another one? Well, I don't know this, but I do know 24 and its side opposite. And so I can say the sine of 24 over 300 is equal to the sine of 128 over R. Cross multiply. And when I do that, I find out that R is equal to 581.2 feet, which makes sense when I'm talking 300, thinking about the sense of my answer. I'm opposite a very big angle, so I need a very significant side. The last example is again a surveying example, and we are trying to estimate the length of a lake as expressed in this picture. Surveyors start at one end, they walk 245 yards, they turn, making a 70-degree angle, and measure back to the other side of the angle, or other side of the lake, to be 270. So how far is it across the lake? Well, this is a scenario where, as much as I would like to use law of sines, I don't know this to go across, and I don't know this one to go across. So my only choice is law of cosines. So I start with the side x squared is equal to 270 squared plus 245 squared minus 2 times 270 times 245 times the cosine of 70. Now these are going to be some pretty sizable numbers. So when I get done, I have x squared is equal to 132,925 minus 132,300 cosine 70. Remember, you must do this side first, that multiplication first. And when I get down here, I end up with x squared is equal to 87,675.7. And so x is 296.1 yards. And again, that feels pretty within reason based on the other measurements we have. So that is several examples and all of the information about the first section. Good luck on your homework.